Question 71. Consider the following two standard electrode potentials. What is the equation and cell potential for the spontaneous reaction that occurs? Okay, so first let's find the cell potential. So we use the positive electrode potential minus the negative. And of course, these will end up adding, which will give us 0.91. So that will either be B or C. Now we need to work out whether it's the iron that's getting oxidized or it's the tin. So looking at the electrode potentials, we see that iron has a more positive voltage. So that means it's more of an oxidizing agent, which is itself reduced. Okay, so iron, we need iron to be reduced. Is that B or C? That will be B. As you can see, it goes from an oxidation state of 3 to an oxidation state of 2, so clearly that's been reduced. And of course, tin is being oxidized, going from 0 as an element to 2. So that would be B. 72. What happens during the electrolysis of concentrated aqueous potassium chloride? Okay. Reduction takes place at the negative electrode, the cathode. So we're using an electrolytic cell. Oxidation always occurs at the anode, which means reduction takes place at the cathode. And in this case, the cathode is the negative electrode. So yes. Hydrogen gas is evolved at the negative electrode. Okay, well, if you need to check that, what you do is write out your ions. So the ions that are involved, we have H plus from the water and K plus from the potassium, as well as OH minus from the water and Cl minus from the chloride. So then what do we pick? Well, at the anode here, because it's a concentrated solution, we pick the chloride ion. If it had been a dilute solution, then it would have been the hydroxyl. At the cathode here, we pick the less reactive, so that would be the hydrogen ion, which means 2 is correct because this hydrogen ion will be reduced at the cathode and evolve into hydrogen gas. The pH of the electrolyte increases, because we're getting rid of these hydrogen ions, so we'll have an increase in pH. We're getting less acidic. So that's D. 73. An aqueous solution of a metal salt is electrolyzed. Which factor will have no effect on the mass of the metal deposited on the negative electrode? Okay, so there are 3 factors that affect electrolysis, and they are the current, the charge, and the atomic mass of the metal. So it's these 3 that will affect, and it's A that won't have an effect. Which are correct statements about a voltaic cell? A spontaneous redox reaction occurs, which converts chemical energy to electrical energy. Yeah, that's right. So the opposite would be for an electrolytic cell. So it would be non-spontaneous, and it would convert electrical energy into chemical energy. Oxidation occurs at the negative electrode, the anode. Yes, oxidation always occurs at the anode, and the anode for a voltaic cell is negative. Electricity is conducted by the movement of electrons through the salt bridge. No, so in the salt bridge, We have ions moving, we don't have electrons. The electrons move in the external circuit. So that will leave us with A. Question 76. Which statement is correct for electroplating an object with gold? Well, if we draw a little diagram, we have our object here. Let's say it's a spoon. We're trying to electroplate it with gold. What that tells us is the electrons will be moving this way, towards the spoon, so that we can electroplate it. So that means this will be the anode, where oxidation takes place. So then our answer will be, let's have a look. A, the object must be the negative electrode, the cathode. Why, yes, yeah, it will be A. 77. Which compound contains nitrogen with an oxidation number of +3? So let's take our first one, NH4Cl. So the Cl will be -1. The H4, that will be +4, which means this must be -3 to bring us to 0, because all these compounds are neutral. So it won't be A. Looking at B, HNO3. This will be -2 times 3, which is -6. H will be +1, so this must be +5. So again, it's not that one. Alrighty, 9204. That will be -8. That will be +4. So that leaves us with D. KNO2. So that will be -4. That will be +1. That will be +3. There we go. 77D. 78. We need to select the correct statements. Okay. Looking at the equation for the reaction, we have the zinc is oxidized. Yeah, the zinc is oxidized. It goes from an oxidation state of 0 here as an element to one of 2+. So the zinc is oxidized. Electrons move from the zinc to the lead. Yes, they do. Because the zinc is oxidized, it's losing electrons. They're moving to the lead, which is being reduced from lead 2+ to the lead atom. And that does happen in the external circuit in the wire. The mass of the lead electrode increases. Yes, it does. So then that's D. 78D. 79. Which process occurs during the electrolysis of molten sodium chloride? Oxidation occurs at the positive electrode anode. Yeah, that's our slogan for this topic. Oxidation occurs at the anode. Why are the others wrong? Electrons move through the electrolyte. Nope, they move through the external circuit. The sodium ions don't go to the anode because they're the positive ions. They will go to the cathode to be reduced to atoms. And the chloride ions won't go to the cathode. They will go to the anode to be oxidized to chlorine, or the diatomic molecule, CO2. 80. What is the name of that substance? So it won't be sulfate. Sulfate is SO4. We have, so this will be sulfide. So that's sulfide. That's sulfite. That's sulfate. So learn the difference. Make sure you know the difference. And then, well, the sulfide has a charge of -2. If we need 2 coppers, it means the copper must be 1. Copper 1 sulfide. 81. Consider the following reaction. Which statement is correct? Okay, well, let's have a look at tin. So tin starts off being 2 plus. And then in the next one, what is it? Well, we have SnO2. So that will be minus 4. That will be plus 4. It's been oxidized. So it undergoes oxidation. It's therefore the reducing agent. Yeah, 81B. 82. What occurs during the operation of a voltaic cell based on the following overall reaction? Okay, so the silver is getting reduced. It's going from a +1 to a 0 oxidation state. And the copper is getting oxidized. So then that means the electrons will be moving from the copper, which is getting oxidized, to the silver. So that will be A or C. And the silver ions, they'll be moving towards the silver electrode. So that's C. 83. Consider the following standard electrode potentials. What is the value of the cell potential? Okay, well, we know the drill here. We take the positive one, we take away the negative one, but what in fact we do is we add, and that will give us D, 83D. 84, we have a very wordy question. We've got two cells. One has silver nitrate solution and a silver electrode. The second cell has copper electrodes and copper 2 sulfate solution. 1 gram of silver is deposited in the first cell, so what mass of copper in grams is deposited in the second cell? Okay, so we have these options here. We don't actually need to work it out, just to know the method. Looking at A, well, what they're doing there is the mass divided by the atomic mass of silver. So what that would give us, without even knowing how to do this question, is moles. And we're not looking for moles. That's moles of silver. Then B would give us moles of copper. So again, we're not looking for that. We're looking for grams of copper deposited. So that leaves us with C or D. And C is the correct answer. Why is that? Well, if you think about the charge of the ions, we have silver plus 1 and copper 2 plus. Why is it 2 plus? Well, we're told here that it's copper 2 sulfate. So if we were to pass, say, 10 electrons through this circuit, how many silver atoms would we get? We'd get 10 silver atoms. But what about copper? We need 2 electrons to reduce it. So then we get 5, only 5 copper atoms. So that's why here we divide by 2, because the grams deposited will be half of the silver. So always make sure you look at the ions and their charges. 86. What is produced at the positive electrode, the anode, and negative electrode, cathode, during the electrolysis of molten lithium chloride and molten lead bromide? Okay. So with the lithium, okay, so let's zoom in. We have lithium chloride. We have lead bromide. There's the anode and the cathode. Positive ions, they go to the cathode, the negatively charged cathode. So that will be Li plus and Pb plus. Plus 2, that is. Then at the anode, we have the Cl minus and the Br minus. All right, so what does that match up to? D. 87. Which of the following redox reactions take place? Okay. I think this is about reactivity. As you know, reactivity decreases down group 7. So we have fluorine being the most reactive, then decreasing reactivity. Okay, so in the first instance, yes, chlorine will swap with iodine. Chlorine is more reactive. In the second reaction, bromine will swap with iodine. Yes, it will. In the third reaction, iodine will not displace bromine because it's less reactive. So that leaves us with A. 88. Which species could be reduced to form NO2? So reduction definitions, we have decrease in oxidation state, increase in hydrogen, decrease in oxygen. So which of these species could do either one of those three things in order to get to NO2? Well, it's definitely not D. If we reduce that even further, we won't be able to get to NO2. If we add hydrogen here, again, we won't be able to get to NO2. Looking at B, we have NO3 minus, so that's minus 6 plus 5. And in our case, we have NO2 with minus 4 and plus 4. So from plus 5 to plus 4, that's a reduction. So that works out. That will be NO3 minus. Consider the overall reaction taking place in a voltaic cell. What is the role of zinc in the cell? So zinc goes from an oxidation state of 0 to one of, well, hydroxyl. That's minus 1. That will be minus 2 because of that there, which means the zinc will be plus 2. So it's oxidized. So the positive electrode, no, not the positive electrode. It's a voltaic cell, so it'll be the negative electrode, C or D. We've just said that it's oxidized, so it'll be the reducing agent, and that's D. Last question. What happens to the manganese in the following reaction? Well, in MnO4, it's minus 8. Sorry, I missed the minus there. Minus 8 for the oxygen, so that would mean plus 7 for the manganese. Here is plus 2, so it is reduced, C or D, and its oxidation number decreases. So that's 90D. Well done if you've made it this far, if you've completed this whole document. If you still have any questions, please comment down below and let me know what other topics you'd like me to complete.